Hi, this is James. Welcome to Homework 6, Problem 1. Remember that it's important to solve the problem or at least work on it for a considerable period of time before looking at the solutions and before looking at a video of the solution worked out. So the problem has three 300 ohm resistors that are connected with a 1.5 volt battery. Battery has a rating of 3 amp hours. So it's 300 ohm resistors, 1.5 volt battery, and the battery has a rating of 3 amp hours, meaning that the charge available is 3 amp hours. Now, that's a little disturbing because batteries are not sources of charge, they're sources of energy. The electrons that move through a battery start in the battery and in the wires and in the devices in the circuit. So the battery is not a source of charge. What the battery does is it gives energy to each electron as the electron goes through it. Or if the current's going the other way, it takes energy from the electrons. In any case, the battery can be seen as a source of energy in some circuits, but not really a source of charge. Anyway, the battery is rated as having this amount of charge supposedly available. The question is, if they're connected, if the resistors are connected in series, how long can the battery supply the resistors with power? And so in series, ordinarily I'd draw a picture. In this case, the problem is very simple. The resistors are in series, so the equivalent resistance is just the sum of the resistances of the individual resistors. There are 3 of them, so the equivalent resistance is just 300 ohms times 3, or 900 ohms. The time that the battery will function for is related to the charge available through the current through the circuit. So current is charge per time. If you multiply that by the time, you get the charge. The current is given by Ohm's law. So V is IR, meaning that the current is V divided by R. So if I plug that into this equation, I get V divided by R times T is charge. If I solve that for the time, which is what I want to get in the end, I multiply by R over V on both sides, and I get that the time is charge times resistance over voltage for this problem. So if I plug in charge is 3 amp hours, and I might as well leave my answer in hours, so I'm not going to convert that to amp seconds. Resistance I figured out because this is in series, it's 900 ohms divided by the voltage, 1.5 volts, and these are nice simple numbers. This is 3 halves, so flip it. When you divide by it, you get 2/3 times 900 times 3, or 2 times 900 hours, or 1800 hours. Or you just plug it into your calculator, of course. So that's the answer to part A with the resistors in series. With the resistors in parallel, 3 identical resistors in parallel, the equivalent resistance is just 1/3 the resistance of one of them. I can show that by 1 over R equivalent in parallel is 1 over the first resistance, which is R, 300 ohms, plus 1 over the second resistance, which is R, plus 1 over the third resistance, which is R. So that's 3 over R. So to get the equivalent resistance, you flip, and so the equivalent resistance is R over 3. Compare that to the resistance in the first part, which was 3R, and you get that the answers, the new resistance is 1/9 the old resistance. So the new answer is going to be 1/9 the old answer because the time is QR over V. It's proportional to R. So with the resistance being 1/9 what it was before, the time will also be 1/9. And so you get Q, if I write it out though, it's Q is 3 amp hours times the new R equivalent, which is 300 ohms over 3 divided by the voltage, 1.5 volts, and you wind up with 200 hours if you plug that into your calculator. And I should have written up here R equivalent instead of R, which is what I was calling the resistance of an individual resistor. All right, so that's the problem. Thanks for listening.